A line has equation y equals kx plus 6, and a curve has equation y equals x squared plus 3x plus 2k. So where k is a constant. So for the case where k is equals to 2, then the line and the curve intersects at the points A and B. Find the distance AB and the coordinate of the midpoint AB. Okay, the second question here under that same question is find the two values of k for which the line is tangent to the curve. Okay, now solution to this given question. Now we are given equation of a line to be y equals to kx plus 6, and we have equation of a curve to be y equals x squared plus 3x plus 2k. So these are the two given equations. The first one is the equation of a line, and the second one is the equation of a curve. So for the case where k is equals to 2, the line and the curve intersect at points A and B. So that means there is a point of intersection between this line and the curve. So meaning that the line intersects the curve. So and the 2 points happen to be A and B. So we need to find the points A and B now when k is equals to 2. So consider A to be 2. That's the first thing. Consider k to be 2. So when k is equals to 2, then we have the equation of a line now becomes 2x plus 6. Okay, and that of equation of a curve, we have that to be x squared plus 3x plus, remember you have 2k there, then that will be 4 now. 2 times 2, that's 4. Okay, so since there is a point of intersection now, we can just substitute now. We call the first one to be equation 1 and the equation of the curve to be equation 2. So when you equate the two equations together, you have 2x plus 6 equals x squared plus 3x plus 4. And this can be written as x squared plus 3x plus 4 minus 2x plus 6 equals 0. And of course, we have 3x minus 2x, that's x. 4 plus 6, is that going to be plus 6 or minus 4? That should be minus 6. This should be minus 6. Okay, so we have 4 minus 6, that's minus 2 equals to 0. And this is a quadratic equation. So one of the methods of solving quadratic equation is factorization method. And we can factorize this. The coefficient of x squared here is 1 and the constant term here is minus 2. So we need product of minus 2 and sum of 1. So we can make use of minus plus 2 minus 1. So you have x squared plus 2x minus x minus 2 equals 0. And this implies that x plus 2, by factorizing x out, then when you factorize minus 1 out there, you have x plus 2 as well. So eventually you have x plus 2, x minus 1 equals 0. And for product of two factors to be 0, so one of the factors must be 0, meaning that x is equals to minus 2 or x equals to what? 1. So we've gotten values of x. Now we now use this value to get y. So we look for corresponding value of y for this particular x. So when x is minus 2, don't forget the new equation of a line that we have here when k is equals to 2. We have that one here. This is the equation of the line, and this is the equation of a curve when we consider k to be 2. Okay, so to get y now, we can just make use of any of this equation to get y, but preferably we should make use of the equation of the line. Okay, because that one is straightforward compared to the equation of the curve. So we have the equation of the line to be y equals to we have that to be y equals 2x plus 6. So when x is minus 2 now, this is y equals minus 2 times 2, then plus 4 plus 6. So from here we have y to be 2. So which implies that y is minus 2 when x is 2. When x is 2. So this is one of the points. Okay. So to get second point now, we consider second value of x. When x is 1, then what will happen to y? That means we have y to be 2 times 1 plus 6. So we have y here to be 8. So the second point now is 1, 8. So we can just call the first one to be A and the other one to be B. So the 2 points are minus 2, 2 and 1, 8. So we've gotten that. Now the question now asks us to find the distance AB. Of course, they didn't ask us to find points A and B, but for us to find the distance between the 2 points, we need to get the points first. So we've gotten the points now. Now we find the distance AB. That's the next thing. Distance AB. And we have distance between 2 points. We have the formula to be x2 minus x1 squared plus y2 minus y1 squared. Alright, so remember the 2 points are A, we have that to be minus 2, 2, and that of B, we have B to be 1, 8. So our x1 here is minus 2, y1 is 2, x2 here is 1, and y2 is what? 8. So by substitution now, we have the distance of the points A and B. We have that to be minus 2 minus 1 squared plus 8 minus 2 squared. Okay, so minus 2 minus 1, that is minus 3, and of course minus 3 squared will give us 9. Then plus 8 minus 2, that's 6. 6 squared is 36. Okay, and square root of 9 plus 36, this is root 45. And don't forget, this 45 can be written as 9 times 5. And 9 is a perfect square number, meaning that square root of 9 is what? Is 3. So this can be reduced to what? 3 root 5. And this is the distance between the 2 points A and B. Now, in that same question, we need to find the midpoint. We have to find the coordinate of the midpoints of A and B, of A, B. We have that here. Find the distance AB, we've gotten that, and the coordinate of the midpoint AB. Now, to get that now, we have formula for midpoints. Midpoints of 2 given points, we have the formula to be x1 plus x2 divided by 2, then y1 plus y2 over 2. And we are still using the points A and B, where A is minus 2, 2, and B is 1, 8. So the midpoints now, that will be x, this is x1 minus 2, x2 is 1, then over 2, y1 here is 2, and y2 is 8, then over 2. And this will actually give us minus 2 plus 1, that is minus 1. So this is minus 1 over 2. 2 plus 8 here is 10, and 10 divided by 2 is 5. So this is the midpoint of points A and B. So what that means is that, let's say we have a line here, and this line joins the 2 points A and B together. So we are now looking for a point that is between, that is exactly in the middle of the line. So, and the point now, we just got that to be minus 1 over 2, 5. And that is the midpoint of the line AB. Okay, so now moving to this second question, where we are asked to find the 2 values of k for which the line is tangent to the curve. This time around, remember the first condition given was k to be 2. So we used k to be 2. We used k to be 2 to get what was it called? The 2 points A and B. But in the case of this, we are not going to assume any value for k. We only need to find the values of k here for which the line is a tangent to the curve. And what that means is that when a line is tangent to the curve, it is just like we have something like this. This is a curve, and we have a line like this. So that is what it means. That means there is only a point of intersection between the line and the curve, and the points of that intersection will be at the turning points for that particular, because the two given equations are equation of a line and a quadratic equation. Okay, so that is what that implies. Okay, now to get that, remember the two given equations from the beginning. We have the equation of a line to be kx plus 6, and don't forget that of curve is given to be x squared plus 3x plus 2k. Now we equate this, meaning that x squared plus 3x plus 2k equals kx plus 6. Alright, so you rearrange this, then you have x squared plus 3x minus kx plus 2k, then minus 6 equals 0. Okay, so the next thing to do now is to rewrite this equation in terms of ax squared plus bx plus c equals 0. And to do that, here you need to factorize x so that you have 3 minus k, and this is your constant term, which is 2k minus 6. Okay, since we've rewritten that in terms of this, now we can now compare this new equation that we obtained now with the general quadratic equation. So by the time you compare that, you will realize that a is 1 here, b is 3 minus k, while c is 2k minus 6. So why do we need to write this in terms of this? Why do we need to find a, b, and c here? Now remember, we have a condition here in that question that line is a tangent to the curve, and whenever a line is a tangent to the curve, what happens there is that the nature of the quadratic must be 0, must be real and equal roots. That's the meaning. So which implies that for you to have real and equal roots or real and repeated roots, discriminant d, which is b squared minus 4ac, must be 0. That is the meaning. Okay, so this is when a line is a tangent to a curve. That means you only have one point of intersection. So when the line intersects the curve at two distinct points, that means your discriminant there will be greater than 0. Okay, so but since the line is tangent to the curve now, so we have to equate the discriminant to be 0. So for that reason, now we make substitution of the constants here. So where b is 3 minus k all squared minus 4, a is 1, and c is 2k minus 6. Then when you expand this, you have 9 minus 6k plus k squared, then minus 8k, then plus 24 equals 0. Okay, so you rearrange this in terms of quadratic equation so that you have k squared minus 14k plus 9 plus 24, that will give us I think that will give us 33. Okay, what happened next is now to find the value of k. Okay, so we need product of 33 and sum of minus 14. So there are only two numbers that will give us, that the product will give us 33, sorry, and the sum to be minus 14. So the numbers are minus 11 and minus 3. So of course this will give us 3, and minus 11 minus 3 will give us minus 14. So we make use of these two numbers, so which are k minus 11 and k minus 3 equals 0. So from here we have k to be 1, or k is equals to 3. So these are the possible values of k for that line to be tangent to the curve. Alright, so don't forget to like, share, and comment. Thank you.